Okay, today we're going to be solving radical equations. This uses what's called the principle of powers. It basically means that if we have a equals b and n is a positive integer, then a to the power of n is equal to b to the power of n. Today we do want to be sure to check solutions, as for some of them may not actually work. So if we look at the first example here, just like some of our other equations, when we go to solve it, we got to get rid of anything outside the parentheses. And technically, in this case, the parentheses is the stuff underneath the radical. So as I go to get rid of it, I got to get rid of the 3 first. So I'm going to add 3 since it's outside. That's going to give me the square root of x plus 8 is equal to 5. Then we have to get rid of the square root. Well, the opposite of square rooting something is to square something. Square something. So x plus 8 will equal, 5 squared is 25. I'll finish off by subtracting 8 on both sides and get x is equal to 17. We're supposed to check this with the calculator, so we're going to pull up Desmos here. And we're going to check this equation with Desmos. So when I go to solve something in Desmos, you can just type it in as is. I don't really recommend that, but I know some of you do it that way. When you solve something in Desmos, I recommend typing each side of the equation in as its own equation. So y equals the square root of x plus 8 minus 3 as its own equation, and y equals 2 as its own equation. Now, the reason why I recommend doing this is, well, even though in Desmos you can type it all in just as is, but other calculators you can't. So typing in as I just did, you can do that in any graphing calculator. To look at the solution, again, the solution is the x value where the two lines that I just graphed cross or intersect. So that's 17, which matches our solution. So it is indeed correct. Oops, I forgot to switch back to, there we go. Now, if we look at this one, we can see that there's a fractional exponent. So at least for Algebra 2 standards, if I see a fractional exponent, I'm going to want to deal with that. Well, the 2 is going to chill. We talked about last week, fractional exponents were radicals. So this is the square root of x plus 5 to the first power, which means we don't really need to put the exponent, equals 8. So usually with fractional exponents, in most cases, I switch it to the radical form. I find it easier to solve myself. So I like to solve it with the radical form rather than the fractional exponent. Just like with the previous problem, if there's anything outside the radical, we have to get rid of it. We have the timesing by 2, so we'll divide by 2 on both sides. We get the square root of x plus 5 equals 4. Now the opposite of square rooting something is squaring something. So squaring and square root cancels. X plus 5 equals, 4 squared is 16. We'll finish off by subtracting 5 on both sides. Give me x equals 11. We do need to double check to make sure it is indeed a solution. So if I plug it back in, 2 times 11 plus 5 to the 1/2 equals 8. Is this true? Well, 2 times 11 plus 5 is 16 to the 1/2. Is that 8? Well, again, an exponent of 1/2 means the square root. So this is twice the square root of 16. Well, the square root of 16 is 4. Is 2 times 4 8? Yes, it is indeed. So it is indeed correct. The next one is a cubed root equation. Now, cube root equations are nice. Odd index equations you shouldn't have to check. It doesn't hurt to check the answers, but you shouldn't really have to check them unless there becomes an extraneous solution. Now, for example 3, notice how we can't get the numbers outside the radical to the other side. So what we end up having to do is just not cube root, it's already a cube root. Do the opposite of cube rooting, which is cubing both sides, so that I can get rid of the radicals. When I cube root when I cube the left side, the cube root and cubing go away, giving me x minus 5. To cube root the right side, because there's two things multiplied together, the 2 and the square of the cube root of x 7 minus x, I have to cube root. I keep saying the wrong words. I have to cube both things. So I have to do 2 cubed. 2 cubed is 8. And I have to cube the cube root of 7 minus x. Cubing the cube root of 7 minus x basically cancels out the cube root, leaving me with 7 minus x. That's a lot of cubes and cube roots to try to say. Now it's a linear equation here, so we're going to just solve it like a linear. So we'll distribute. Give me x minus 5 equals 8 times 7 is 56. Minus 8x. We'll move all the x's to one side. So add 8x to both sides. Give me 9x minus 5 equals 56. I'll add 5 to both sides. Got 9x equals 61. And then divide by 9. Get x equals... well, that's beautiful. 61 over 9. So that's not the prettiest thing. I think I modified this equation so it doesn't really work out pretty. I'm just going to check in Desmos. 61 over 9 as a decimal is about 6.7 repeated. So we're going to check to see if Desmos will come up with the same thing here. Maybe I should have worked this problem out beforehand, before using it. Make sure it came out a little bit nicer. But we're going to just check it out in Desmos. So I'm going to type each side in as its own equation. The cube root is under functions. So the cube root, come on. So we got y equals the cube root of x minus 5. And y equals the cube root under functions again of, 2 cube roots actually. 2 cube roots of 7 minus x. The two intersect at, if you look closely, it's hard to see because it's probably pretty small, 6.788. Again, we're only looking at the x value because that's the only variable we have. We only have one variable in the original problem. So 6.778, which is probably the 6.7 repeated that we got when we solved it. So 61 over 9 works. You can also try to solve this by hand, but that would be a pain with this particular thing. So yeah, that's it. Now the last example is a more advanced one. I may or may not do this actually in class, but for this example, notice everything outside the radical is already on the right. But we can't actually simplify this stuff over here. So when we go to get rid of the radical, which would be our next step, we get rid of the radical again by squaring. So squaring a square root cancels, leaving me with x plus 5. Not x plus 5, x plus 2. But on the other side, because this is in parentheses with addition or subtraction there, we actually end up having to write it out twice and distribute. So 5 times 5 is 25. 5 times negative 2x is negative 10x. Negative 2x times 5 is negative 10x. Negative 2x times negative 2x is positive 4x squared. I'll simplify the right side. So x plus 2 comes down. Equals, let's see, 4x squared minus 20x plus 25. It's a quadratic equation, so I'm going to move everything to one side. I'll subtract x from both sides. And I'll also subtract 2. I'm going to do it in the same step here. So I get 0 equals 4x squared minus 21x minus, plus 23. So I have to solve this equation. I can either use the quadratic formula or zero product property. I'm going to try zero product property. So first times last, just trying to factor. 4 times 23 is... Actually, I don't think zero product property is going to work now that I try that. So I'm just going to try quadratic formula. I'm not sure zero product property will work. So negative b, so negative 21, plus or minus the square root of b squared minus 4 times a, which is 4, times c, which is 23, all over 2 times a, which is 4. That's a horrible 4. I'll go through just like we have done in the past. Positive 21 plus or minus the square root. So the square root of, actually not typing in the square root, 21 squared minus 4 times 23 gave me the square root of 73 over 8. And unfortunately, 73, I don't think you can get any factors of. Divided by 3. Yeah, we're not going to be able to do any real factorization with it. So 21 plus or minus the square root of 73 over 8 is our two possible answers. I'm just going to double check this in Desmos. I could plug back in. Okay. So I'm going to pull up Desmos here to check. Otherwise, it might be a pain to do by hand. And these problems don't necessarily come out irrational. I just apparently did not do a very good job of choosing nice looking examples today. Oops. Come on. There we go. So y equals the square root of x plus 2. And y equals 5 minus 2x. So that's my solution right there, that 1.557. But I'm going to figure out which of the two exact answers that is. My two exact answers. Oops. Let's see if I can get it to cooperate with me. Apparently I can't. So I'm going to have to get rid of this. My two exact answers are 21 plus radical 73 over 8. And 21 minus radical 73 over 8. I'm just going to type these into my calculator here. I'm going to use parentheses around this when I type it in. So I only had one actual answer, 21 plus the square root of 73 in parentheses divided by 8. That comes out to be 3.693, which is not the answer that I had. And if I type this one in, come on, there we go, minus, and then divide by 8, I get 1.557 if I round to 3 decimal places, which is the answer that I want. Now these are this example wasn't the prettiest, but it gets the point across. If you have two terms like we did here, you end up having to FOIL.